Imagine your software's core logic as a vault. If you let chaotic, corrupted data slip past the front door, the entire system is at risk. In a typical application, an invalid state happens when an entity, let's say a gathering or an event, gets created with impossible details, like a negative number of attendees. To stop this, we build a protective layer right at the entity's boundary. This is called domain validation, a strict set of rules deflecting bad inputs before they ever reach your database. When working in .NET 10, there are two highly effective production-ready architectural patterns to enforce these rules. You can either halt execution entirely using custom exceptions, or you can explicitly handle the failure paths using the result object pattern. Choosing the right strategy for your specific application prevents silent failures, keeps your data clean, and saves hours of tracing bugs. Let's look at the first approach, throwing custom exceptions. The mechanics here are straightforward. The exact moment a domain rule is broken, your code throws an exception, and execution immediately stops cold. Take a look at this code snippet. We start by creating a base domain exception class, taking advantage of .NET 10's primary constructors to keep the boilerplate to an absolute minimum. From there, you inherit from that base class to create a highly specific error, such as a gathering maximum attendees exception. You throw this exact exception when the attendee rule is violated. The main advantage of this strategy is visibility. When your code stops cold, the framework automatically generates a stack trace. A stack trace is a detailed report showing the exact sequence of function calls that led to the error. Because you have that sequence logged, developers monitoring the system can pinpoint the exact line of code that failed without guessing. Throwing an exception carries a hidden performance cost. In a high-traffic application where validation fails frequently, generating all of the stack traces will quickly drain your system resources. Exceptions act as a blunt instrument. They are perfect for catching catastrophic, system-breaking errors, but they can be too heavy for routine validation checks. That brings us to the second approach, the result object pattern. This strategy allows you to return a failure gracefully, completely bypassing the performance penalty of throwing an exception. Looking at this result class structure, you'll see it relies on a simple Boolean flag, indicating success or failure, alongside an attached error record to explain what went wrong. That error record requires two specific components: a unique identifier code, so the system knows exactly which rule failed, and a descriptive message to provide context for debugging. Notice how this changes the execution flow. Instead of abruptly crashing and stopping, the program hits a validation check and smoothly diverts onto a designated failure path. Because you are returning a specific object, the failure is explicit in your method signature. This is the exact opposite of exceptions, which are very often completely hidden from the developer calling the method. By using result objects, you force the calling code to consciously acknowledge and handle the failure. This creates predictable, stable software that doesn't rely on catching surprise errors. However, if you start creating new error instances directly inside every validation check, your code base will quickly become messy and hard to maintain as it scales. The solution is to abstract all of your possible domain errors into a single, centralized catalog. Here in this domain errors class, we organize everything cleanly using nested static classes categorized by the entity. Now, we have a clean list of reusable errors, like gathering.alreadyPassed. Let's apply this catalog to domain logic, like a method for sending a gathering invitation. First, we update the method signature. Instead of returning an invitation object directly, it now returns a generic result wrapper that contains the expected invitation. Looking at the implementation, the flow is clear. If a specific business rule fails, we return a failure state directly from our centralized catalog. If the rules pass, we simply return the new invitation. But pay close attention to the calling application. The developer implementing this method must explicitly check the isFailure flag on the returned result. If they forget, the validation logic is ignored entirely. When executed correctly, pairing a centralized error catalog with result returns gives you a highly readable, self-documenting domain layer. Now that we have built out both .NET 10 validation strategies, it's time to review your options. The custom exception approach offers fast, highly detailed debugging capabilities, but it charges a heavy performance tax when errors occur frequently. The result object pattern protects your performance and makes failure states explicit, but it requires strict developer discipline to manually check those failure flags. This comparison matrix lays it out clearly. Neither approach is universally better. They solve different priorities within your system. Mastering both patterns ensures you protect domain integrity while balancing performance and developer experience in enterprise applications.